built-in secret in a project that has taken 3 years, 50,000 design hours and 200,000 hours in construction, the new Gitana 18 is aiming to be the fastest offshore machine in the world. Given the level of sophistication and radical thinking that has gone into this new Ultim, there's good reason to think that she could be just that. So we went to find out more at her launch in her home port of Lorient on the west coast of France. But first, we asked designer Guillaume Verdier, who is one of the design gurus in the world of high-performance offshore machines, what's special about an Ultim.
I mean, this kind of boats, they cross the Atlantic, in less than 3 days. They manage to sustain 38 knots average, and they don't need to stop for refuel. There's no boat that are capable to go around the world non-stop without refueling, except nuclear submarines.
So the Ultims are without question freaks of technology, and Gitana 18 is looking to raise the bar even further. At 32 metres long, 23 metres wide and setting over 630 square metres of sail downwind, any Ultim trimaran is an impressive beast. Since they've climbed up onto foils, they've become breathtaking, and their offshore performance has been staggering. Gitana 17 led the foiling charge in this class, and now Gitana 18 represents the next generation. Built in secret, since her launch it's become clear that it's been a mammoth project. 50,000 hours of design and 200,000 hours to build her. By comparison, an America's Cup AC-75 takes around 50,000 hours in a team of around 100 staff. Team Gitana has 25. Like her sister ship, Gitana 18 has been built to take on the world's biggest ocean races, both fully crewed and solo. And while she may have the same dimensions as other Ultims, it's the technical aspects and refinements that make her stand out. According to the team, this is not just an upgrade, this is a complete reinvention. Every aspect of the new machine, from the hull shapes, foils, appendages, structure and onboard systems, has been redesigned to deliver the fastest and most reliable offshore trimaran in the world. In many ways, that's an easy and predictable claim to make, but when you drill down into the detail, you start to see why. Where her previous sister ship was designed to fly in optimum conditions, Gitana 18 is designed to fly all the time. And when that comes to big ocean swells, that is no simple objective. No one in the sailing world has cracked this so far, and yet everyone now knows that this is what the future holds if the offshore speed bar is to be raised. But one of the really telling things about this project is that it's not just about making the boat faster. Instead, it's much more about making it smarter.
The objective is to go around the planet in the Southern Ocean, go to bed and have a stable flight, and having a foil that you can, move inward, you can reduce your righting moment. It helps a lot at having a stable flight. So you can go closer to, your optimal simulation, dream speed, let's say.
On the boats as we had before, on most of the boats, you have an L foil, for example. On an L foil, well, once you've designed it and you've finished its shape, well, it will produce a certain amount of vertical push and a certain amount of side force. And once the design is done, you can't really change it. And what we wanted on this boat to say, well, we don't want to have a boat with compromises. So that means in the real life, the ideal life, you would like to have a foil where you can change quickly the side force and the vertical force. And that's where we came with this a bit Y shape and with two flaps. And the idea with those two flaps is really to be able to set in 3D the foil and to maximize, the loads in every direction. And so, like that, we can really have a foil downwind, for example. We can have less side force and more push force, and well, you can really set it in 3D.
The sweet spot as well is when you go reaching, because you can externalize the foil to the maximum of the beam of the boat. You've got the tip of the foil which is touching the outside of the box. I mean, the box is 23 meter wide, you know. You gain a lot of righting moment. We are a lot more powerful. On the other boat, the foil was coming out of the float and going inside, and we were losing a lot of righting moment because the foil was a bit in between the main hull and the float. And so this opportunity we have to be able to move inside, outside the foil is a huge drive of performance for us.
We've worked a lot on the structure and a lot on the hydrodynamics. So all the profiles have been rethought, and also the materials. So now the wing of the centerboard is fully machined into a block of metal, a bit like what they did on the Cup in the time. And that's to try always and get the maximum of performance and rigidity out of the wings, so that we push the most possible with the smallest surface, basically. And well, obviously we always have on the centerboard those flap, a vertical flap and a horizontal flap, so like that we can kind of have the most maximum of settings possible to sail the boat. They're more than 4 meters high, so that's more than 1 meter more than the previous boats where the rudders were already big. And so coming with this size, well, obviously we faced the challenge of structure, and that's where we, with Guillaume, started to have the idea saying, well, if we had to hold, you know, a rudder that's 4 meters high, how are we going to do that? Well, one way of doing it would have make a massive big rudder in the water and make it hold, and that was not performing anymore. And that's where we came with those idea of the two branches, you know, to hold the elevator and basically to have a more stable direction. The other thing of those rudders is they don't rotate, you know, they stay in the flow, and we only move the flaps behind. And came with that also an idea of trying to be more efficient with the energy in the autopilot, because obviously you need less energy to move a flap than to move a whole rudder. So it's a whole compromise between structure and optimizing hydrodynamics and the autopilot. One thing people have to understand is before on those boats, the limit was not really the boat itself. We spent our time trying to make Charles around the world, he spent his time trying to make the boat go slower. And one of the reasons was because in big waves, the rudders, when the boat jumped in waves, were coming out of the water or were deforming a lot. And so, you know, sometimes we had little loss of control. And for that, we were like, you know, slowing down the boat. And on those rudders, the idea is to say, hey, it's a shame to do this machine and having to slow it down. Let's try and use 100% of the performance. And I think there will be a bit gain at the end on the rudders, because if we're able to sail 45 knots all the time because of the rudders, well, at the end they'll have a big gain in performance.
Yeah, it comes from the computer, from our experience. We say we don't have enough control. Sometimes we have to ease the sails because we lost control, because we fly too high and we don't have enough rudder in the water. And the problem is the rudder, and I told them the rudder are not stiff enough. Okay, but so it's very complicated. They told me, you want a longer rudder, but stiffer. It was just impossible to build, except to do a very large one or a metallic one, which is very heavy. So Guillaume imagined this solution and very quickly realized it was very interesting for many reasons. And we make this choice. But, okay, let's go to this way. But after, we are going to build it, we're going to go up and down. That was a big challenge, and we found solution only a few weeks ago.
There's a real deal with the energy on board and how you're able to sail these boats. And most of the time, in the sail shapes or the sail configurations you're using, you're always doing a compromise. If you take an example, when you're single-handed, and Charles sails on his own on the boat, most of the time he's adapting the power of the boat or the configuration of the mainsail, for example, to something that's going to come in a few hours, or because it takes a lot of time. You know, taking a reef, for example, is a big effort. It's 20, 30 minutes. So the first idea was to try and say, okay, a bit like the foils actually, where we want to be able to have more possible configurations, was to say, how could we more efficiently and more quickly change the sail shape, but the power of the boat. It's not only a thing of having a best aerodynamic shape, it's how do you manage to do that the quickest possible and the most efficiently possible. And that's where came the idea of bending the mast with those spreaders.
You want to take off early, so you need to have a deep, powerful sail. And as soon as you go fast, you want to make it flat. I mean, it's like in any dinghies, okay? There's no revolution in any of these things. But make it happen on a big boat, you know. These masts, like on Gitana 17, the mast is not moving at all, you know. You flex it by 5 centimeters, no more, or maybe 10, but here it's a lot more, you know.
But the mast is a revolution for wing counting mast, but it's the same process as most of the masts, especially, for example, on the Volvo. It's you want to bend the mast, but it's very simple when you have a backstay and things like this on spreaders. But on a wing mast, that was very complicated because it's very stiff longitudinally. So how we are going to do it, and we want to do it with the minimum of power because I'm alone on the boat when I want to change it.
To give you a bit of an example, if you're on the boat and the gust comes in, what would you do usually is ease the mainsail. In the mainsail, there's between 18 and 20 tons of load. So when you've eased it, you have to grind again to bring it back in, and that's a lot of effort. To move the spreaders, it's 1 or 2 tons, so it's a tenth of the power needed to, you know, depower the main. So it's at the end, it's a more efficient way to, you know, set the power of the boat.
You need power to start flying, especially in the light air. And as soon as you fly, you always have too much sail area. So, and we cannot change the front sail. It's very complicated to change. And if you have a big front sail, it's easy to start to fly, but at the end, as soon as you fly, the sail is too big and drag a lot. So what is the way? Is the way they do on the America's Cup boats. They can have lots of power just to take off. And as soon as they take off, you have lots of wind in the sails because you go fast, so your upper wind speed increase. Then you need the flatter sail. So it's really make a super turbo as soon as you fly. And when you need power, it's very easy to go back to maximum power on the main sail. So that's a huge gap, I think.
Well, we've worked a lot with all the team of North Technology Group and Southern Spa, and they really had the really good and efficient tools to have all the loop of design with us and work with the sail and the mast together, so that was really good. And well, obviously bending such a big carbon, we don't see it here, but it's a really big carbon section. And bending a big carbon tube is never something easy. So yeah, the challenges were more to be able to bend so much a mast without making it too heavy. We have to be very efficient on our boats because, as you said, we don't have any other power than the skipper or the crew grinding. So on that, we worked a lot with Raken to try and develop, you know, new pumps and the most efficient pumps, for example, possible. But then it's not because you have a lot. You have to understand, it's not because you have a lot of cylinders that you use more power. At the end, I mean, those cylinders, the boat is auto-stable, so when they're closed, you're not using any power. The idea, again, is to maximize the number of settings possible. And a lot of those cylinders, you don't need a lot of power to set. You know, for example, moving a flap on a foil needs much less power than if I'm moving the whole rake of the foil. So at the end, it's funny to say, but we managed to be nearly more efficient than before because we have more small settings, you know. But then it also comes with, well, obviously a lot of complexity, having 44 cylinders and all the manifolds that go with it and all the electronics that go with it. Obviously it's going to have to be reliable, and a lot of the work's going to be managed to have so many cylinders and being reliable. I think a good example of that is on the Cup, they have way less cylinders than we have there, but they have the same level of engineering and electronics involved. But when you look at the startup procedures of those boats, every day they have to go out of the water. There's a whole team to start it up, to program the boat. And we have to be able to be reliable for a long time, and for one person to start the boat on its own, I'd say.
If you want to increase the stability of the boat, you need fast flap movements. The speed at which your flaps are moving, I mean, it depends on the human capability. If you are on a steering, for example, which is allowed here to have the flap movement of steering, because now it's a flap, the rudder, it requires energy. So you need to make a boat that is stable with a minimum energy, really, and it needs to be stable with no energy at all. So you can't have, you know, here the flap moving with electricity, because it has to be human. So you could if you want, but we've got to have all the configurations working, so that's a challenge, to make something stable and doesn't require too much energy to be efficient.
I did not sail the last years because I spent 99% of my time working with a guy. Sometimes I just listen and watch, but the main difference between before is that we have now simulator, so we have a twin boat on the simulator, and we really we have spent hours, especially one while of sailing on this boat on the computer, and made some feedback to the designer, and they really changed a lot the design of the foil following our feedback. So that was very interesting, and yes, that's the first time I'm going to sail on a new boat, but I have already spent hours and hours of sailing virtually, but that's very interesting, and that's really changed the design of the boat. Well, very simple. Sail as much as possible, but I mean, I don't know many days, because, you know, if you have one problem, sometimes the boat can be stopped for 3 weeks for 1 month. You don't know. So the goal is, I hope we have no surprise and we will be able to learn how to sail. So I need to spend a maximum time sailing. The Hydrodynamics is in November, so it's tomorrow for us. Yeah. You know. So we are 100% focused on this race. We have a race before in Mediterranean, a crew race, but that will be the first taste of the boat. We will not be ready for sure. It's just impossible. The goal is to be ready in 9 months, which is a huge challenge for this kind of boat. At least 3 years to make the boat reliable. And also the problem is we have to find an opportunity on our calendar where there is no race during the winter, and we can do the race. But that's one of the main goals of this boat. But I can't imagine try to do it before 2029, because, yeah.
This kind of boat, what is really cool is sailing upwind. Is so you fly upwind, and it's something everybody, I think, who sail can dream. Flying upwind, don't be too much. So and the speed you achieve, it's crazy upwind. It's more than 30 knots sometimes, with a really nice angle. So I think, and you fly on 2 meters high wave. So it's for me, flying upwind is a bit crazy, and it's really efficient for this kind of boat.
Well, it's a huge boat, and when you are alone, it's really special, because it's so fast, and the fact to fly is just amazing. I mean, it's something we did not imagine 10 years ago, and that it's just perfection. It looks like, for me, it's a perfect boat. You know, sometimes when you sail upwind, and it's a nightmare to sail upwind because it's slow, and with this boat you are sailing at 30 knots upwind. Even if there is sea states, the foils make like suspension. So it's only pleasure. Honestly, most of the time it's 100% of pleasure, which is not the case, you know, when you are a sailor, you know, but most of the time say, why I'm against offshore.